So we're talking about adding and subtracting radicals, and if you know how to add and subtract x's and y's, polynomials, which you did in grade 9 and have done since grade 9, you know how to add and subtract radicals, sort of, but they just look a little different. So we just treat them, if they have the same thing under the square root, we can add them together because we treat them as if they're like x's. So imagine this was 2x plus 3x, I could add that together, get 5x. So in the same way, you can add 2 root 5 and 3 root 5 and make it 5 root 5. But you can't add anything that's not the same under the square root. Okay, so if it's the square root of 5 and the square root of 5, no problem. You can just have 5 of those. But we can't add it to root 7. So when you think about adding and subtracting, you essentially just have to try to get the same things together. But sometimes they don't look like the same thing. Okay, so I'm just going to do, I'll erase this before I go through it, but when you look at something like this, it doesn't necessarily look like you can put them together because the thing under the square root, and I'll just put 27 under here, the thing under the square root does not look the same. So you could say, well, I can't do that. But before you make that determination, you have to simplify these entire radicals as much as you can by making them into mixed radicals. So if you remember from the previous video, we have to write 75 as 3 times 5 squared, and 27 is 3 times 3 squared, 3 times 9, so 3 times 3 squared. And then I remove those bases and make it 2 times 5 root 3, and this becomes 3 times 3 root 3. And then that's 10 root 3, and that's 9 root 3. So together, now I can add them together and make 19 root 3. Okay, so sometimes when it doesn't look like you can add them together, you still can. You just have to do a little bit of work first. So in terms of the steps we have to follow, this is what we're going to say. The first step that we're going to do is we are going to simplify all radicals. Okay, so we're going to make them as simple as possible under the radical. So we're going to essentially take anything that's a mixed radical and still look at the radical, see if we can make it even smaller. And we still need to try to make it smaller, even if it already is a mixed radical, but it's not quite as simplified as it could be. So we want to make them as simple as possible under the radical. And then we add like terms. And actually, I guess we could say we could add or subtract like terms. We just put the terms together at that point. Okay, so that's the process we're going to follow. If you're in your textbook on page 276, here are some questions where it says add or subtract radicals. So it says root 50 plus 3 root 2. So we'll do that one first as another example. So we go root 50 plus 3 root 2. This is on page 276 of your textbook if you want to follow along. And so what we have to do first, we try to simplify as much as we can. Root 50, we can simplify that because we can write it as 5 squared times 2, because it's 25 times 2, and then plus 3 root 2, which makes this then 5 root 2 plus 3 root 2, and finally we can then add them and get 8 root 2. So that's the concept of adding and subtracting radicals. You just find the like terms by simplifying and then add them together. Okay, so let's look at another example. The second one here says negative root 27 plus 3 root 5. There we go, plus 3 root 5, and then minus root 80, and then plus or minus 2 root 12. Okay, so if we try to add all these together right away, you'll notice that everything under there, under the radical sign, so all the radicands are actually different, so we can't do anything with them. But if we look at root 27, we just did that in the previous example, so we can know that that's 3 root 3, and if you're not sure how I got that, just look back a little bit in the video. This is 3 root 5, that's as simple as it gets. Root 80, you can try to figure out a perfect square factor of 80. Okay, so 80 is 16 times 5. So that's going to become the square root of 4 squared times 5. And then 12 is 4 times 3. So this is going to become 2 square root of 2 squared times 3. So we're going to have, when we simplify further, minus 3 root 3 plus 3 root 5 minus 4 root 5 minus 2 times 2 root 3. Okay? So then I look at my like terms and I notice that that's a root 3 term and this is a root 3 term. So I'm going to have minus 3 root 3 minus 4 root 3. And then these two are both root 5. So I have 3 root 5 minus 4 root 5. And then I put them together. So I get minus 7 root 3 and then minus root 5. Minus 1 root 5 if you want to, but that you don't have to write the 1. And that's my answer. I can't go any further than that because all like terms have been added together. So that's how you add and subtract like terms or radicals in general. We're going to do the third example, which is root 4c minus 4 root 9c. So 4 root c minus 4 root 9c. Okay? And you'll notice that it says c has to be greater than or equal to 0. The reason it says that is just because c being negative would make us take the square root of a negative number. And that doesn't give us a real number answer. So we don't allow that. So that's what that's doing there. It doesn't really affect what we do in terms of adding them together. It's just a statement that makes it so that it's mathematically going to work. So we have 4 root c. That's simplified as much as it's going to get. This, though, what's the square root of 9? So the square root of 9 is 3, so I can write this as 3 root c. I can take that 9 out. So that gives me 4 root c minus 12 root c. And 4 minus 12, then I can put that together because they're both root c. So I get minus 8 root c, and then we can again carry the condition that c has to be greater than or equal to 0. So that's how you add and subtract radicals. And if you look on the next page, you'll see what is the purpose of this. I guess there's an example here that shows you when you might want to do that. Okay, so you find this length here. It says what's the distance across the base, and you use the Pythagorean theorem if you have all 3 sides in a triangle, or you use right angle trig if you only have a side and an angle. In this case, we have a side and an angle. Sorry, you use Pythagorean if you have 2 of the 3 sides, or you use trig if you have a side and an angle. Here you have a side and an angle, so they solve for x, which is this distance, by doing tan 30 is 40 over x, and then do tan 30 is 30 over y, solve, and then add together. Okay, so it's just kind of an application of that. But then there's a bunch of questions on the next page that ask you to express them in mixed and entire to mixed, and then a whole bunch of adding them together. All right, and in each case, you're just trying to find something that's common under the radical. We haven't done anything with higher powers, so let's look at one that requires us to do that. Let's look at this guy. Okay, so we have minus 4 cube root of 625r and then we're adding it to the cube root of 40 r to the 4th? Yes. Okay, so again, the first thing we're going to try to do is simplify this. So that needs a perfect cube, and 625 is 25 cubed. So we're going to write this as the cube root of 25 cubed multiplied by r. And here, 40 has a perfect cube in it because it's multiplied as 8 times 5, and 8 is 2 cubed, and then we get r cubed and r. We're splitting our variable. You remember from previous video that r cubed and r gets split out like that because we wanted something that's divisible by 3 and something that is then left over. So this becomes minus 4 times 5 cube root. Sorry, an extra 5 in here. 625 is 5 cubed. 25 cubed is not 25 cubed. It's 5 cubed times 5, and I put that in there wrong. So let me just fix that. My bad. 5 cubed times 5. There we go. That looks better. So we get 5r left in here. And then 8 is 2 cubed, so we get 2. And r cubed, we divide that by 3 to get r. And it's the cube root of 5r. And then we have minus 20 cube root of 5r plus 2r cube root of 5r. So then we add those together. Now, the odd thing about this particular one is that you can't actually add them together. So you can write it like this, and then write cube root of 5r. And we're done.